Hi everyone, this is your Dr. Bitla Venu. In this session, we will see the isometric drawings. In this session, I will tell you what exactly the need of the isometric drawing. Then I will tell you what are the different terminologies related to the isometric drawing. Then we will also see what is exactly the isometric scale and true scale. We will see. Then after looking into the terminology, then we move forward to draw the isometric views of the plane figures like circle, rectangle, hexagon, pentagon we will take. Then we will try to draw the front view and top view for the plane figures as I said just now. Then I move forward to draw the isometric views for the three-dimensional figures. Then I move forward to see what exactly the introduction part now. Then isometric view is basically the drawing which shows all the dimensions of the figure or all the dimensions of the object. That is what we require the isometric drawing. Isometric drawing is a pictorial projection which shows all the dimensions of the component in one view. For that, we require isometric drawing. The isometric drawing is going to carry the actual sizes. That means the actual sizes are represented. The isometric drawing is drawn by using the actual sizes of the component. Whenever we want the actual sizes, we can measure from the isometric drawing. This is the need of the isometric drawing. Isometric drawing is the drawing or the pictorial projection of the component which shows all the drawing or all the views in a single drawing is called the isometric drawing. It also tells us, it also shows the actual sizes or actual dimensions of the component. This is the need of the isometric drawing. Then when it comes to the typical condition, the typical condition of the isometric drawing is the three axes which represents on which we are going to draw the isometric drawing are located at an angle of 120 degrees, equal angle. The three axes on which we are going to draw the isometric drawing or the view, those three axes are located with equal angle, that is 120 degrees. This is the typical condition of the isometric drawing. Then the three-dimensional drawings can be photographic, or it can be termed as a pictorial drawing. In the case of three-dimensional drawing or orthographic or pictorial drawing, the height, length, and depth is not having any relation. That means it can be length, depth, and height can be represented in any of the axes, as you can see like this. You have a square prism here on which you can see this will be the height and this will be the length and this will be the depth. Then, but whereas when you see the other drawing for the same figure, sometimes, as you can see, the intersection point of the axis, the three axes on which we are representing the three-dimensional figure is represented or intersecting at this location or meeting at this location. But whereas in this figure, the three axes are intersecting at this location. So there is no specific rule in the case of photographic or pictorial drawings. Whereas in the case of isometric views, we have specific rule to represent the length, width, height and depth, and all the axes are having the equal angle, the angle between the three axes where those are going to meet, in between those axes, the angle is 120 degrees. This 120 degrees is constant. As you can see here, in this case, the axis is, the angle between these three axes is not same. Then I move forward. As you can see, in this case, the isometric drawing, this will become height, and this will become length, and this will become depth. This representation, the convention is same. As you can also observe, the angle between these three axes on which we are representing the isometric view of the component, the angle is constant. That value is 120 degrees. As you can see here, the angle between D and up to here, and at this line, angle between these two, axes, and angle between these two axes is equal, and that angle is 120 degrees. And even you can take this component also. In this also, the angle between these three axes is same, and that value is 120 degrees. Then let us see some important terms related while drawing the isometric views. As I said, you consider the same figure that we have seen in the last slide. It is height, and it will be the length, and it will be the depth. The three lines, that means AD, AL and AH, where these three axes are meeting at point and at an angle of 120 degrees. These three axes, namely those are AD, AL and AH. These three axes are meeting at point A and making an angle is 120 degrees with each other, and these axes are called the isometric axis. The axis on which we are going to draw the isometric view is also called as isometric axis. Then the lines parallel to these axes are also called as isometric lines. As you can see, this line and this line, and the lines which are parallel to these axes, that means isometric axis, is called the isometric lines. The planes representing the faces of the cube and as well as the planes parallel to these planes are also called the isometric planes. As you can see here, you consider this figure. This is the isometric plane DAH, and LAH is also isometric plane, and similarly DAL is also isometric plane. The planes which are attached to which are connected to the isometric axis are called the isometric planes. In other words, the planes which are parallel to the isometric planes are also called as the isometric planes. So we have these three isometric planes, and the planes which are also parallel to these three can also be termed as isometric planes. Then when it comes to the isometric scale, whenever we hold an object in such a way that to observe all the faces of the component or all the dimensions of the component, so that when the observer to observe the component, we are holding the component to see all the dimensions or to see all the faces. To the observer's side, the appearance or the lengths are not true lengths. So those lengths will reduce some extent because we are twisting the component to a certain angle to view all the faces, all the dimensions of the component, so that the lengths or the edges of the or the lines of the component will be at an angle. So the dimension that we are observing may not be the exact dimension. So there is some reduction in its length. When you twist a component, the observer, whatever the dimension the observer is observing, that dimension is not true length or the not true dimension. There is some reduction, and that reduction is possibly about 0.8152 or the 9 by 11 approximately. This is an approximate value. So it forms a reducing scale because we are twisting the component to view all the dimensions or to see all the faces of the component. It is going to form a certain scale because it is reducing some specific value. So that, use it to draw the, to draw the isometric projection. So we must require one scale. That scale is also called the isometric scale. So one scale is used to draw the isometric projection, and that scale is also called the isometric scale. In practice, while drawing the isometric projection, it is necessary to convert the true length. Whenever you want to draw the isometric projection, we have to convert the true length into isometric projection. Then we have to draw the projection. This is what we require to convert to draw the isometric projection of the component. So in this figure, you can see this is exactly the true length, which is divided into 5 equal divisions, as you can see here, and this will be the true length of a line OD at an angle of 45 degrees now. The isometric length will be at an angle of 30 degrees. These lengths needs to be projected to draw the isometric view of the component. Then isometric projection of the component. But here you can see there are types of isometric drawings which may be isometric view or which may be isometric projection. So you can observe one figure here. So this represents one three-dimensional figure. This is the isometric view. That means this figure, or on this figure, we need to assume that the dimensions are the true dimensions. Whenever it is specified, whenever the component or the drawing is specified as isometric view, the dimensions are the true dimensions that we need to note in our mind. Then whenever a component or a drawing or the three-dimensional drawing is mentioned as the isometric projection, so in that case, the dimensions are reduced. All the dimensions are not original dimensions. Those dimensions are reduced dimensions. As I said just now, isometric view will tells us the true dimensions, will shows the true dimensions of the component. The isometric projection will not show the true dimensions, which shows the reduced dimensions. You can see here. This is what the scale we use to convert the true dimensions to the reduced dimensions to draw the isometric projection of the component. Now let me move further to see the different, isometric views of the plane figures. Now I am considering the different shapes. First I am considering a rectangle, ABCD, and the isometric view can be front view or it can be top view. When we see the front view or in the front view of a shape, In all the isometric views, in the front view, we will get the vertical and 30 degrees lines. Blindly we can remember. In front view, we will get the inclined line, which is at an angle of 30 degrees with a horizontal, and we will get the vertical line in front view. Whereas in top view, we will not get the vertical line, we will get all the 30 degrees lines with the horizontal line or with the horizontal axis, which may be positive or negative horizontal axis. So as you can observe here, this will be the height and this will be the length. Then draw a vertical line with a convenient length. This will become our height, the height of the rectangle. Then draw a line, construction line at an angle of 30 degrees. And this will be the length. As you can see, BC will be the length and AB will be the height. Then specify the same dimensions along length and along height. On the length at an angle of 30 degrees, the length on the line at an angle of 30 degrees, the height which is perpendicular to the horizontal line. Then specify all the dimensions on this plane. This will be the front view of the rectangle. Then, as I said, in the top view, we have only inclined lines which are at an angle of 30 degrees, as you can see here. BC will be the length at an angle of 30 degrees. AB will be the depth at an angle of 30 degrees. But when you see from the top, the plane looks like this. In the even we take the three-dimensional component. When you see the top view of a rectangular block, the top view looks like this, and front face looks like this, and top face looks like this. Now try to note that the angles are 30 degrees, and even at the D also you can see this will be the 30 and this will be the 30 with the horizontal axis. Even you can see here at point C also the angle is 30, and here it is also 30. Everywhere the angles are 30 degrees with the horizontal axis. Whereas in front view, we have the perpendicular line and as well as 30 degrees line, as you can observe in the rectangle. Now let me take one more plane. Now I am taking a triangle here. This I'm enclosing. This triangle I'm enclosing in a rectangle like this. Then draw a line, draw a construction line, which will be the length of the triangle at an angle of 30 degrees. Draw a vertical line. That will become the height of the triangle. Then represent these dimensions on this length and height. Construct a rectangle first. 1, 2 and AB similar with the similar dimensions of the triangle and rectangle that we are constructed for the triangle. Then look at a midpoint here, and that will become the point 3. Then join 1 and 3 and 2 and 3. You will get the triangle. You will get the front view of the triangle plane. Then I would like to represent the triangle on the top view also. Then draw a line at an angle of 30 degrees and draw one more line at an angle of 30 degrees to represent the depth, and to represent the length, draw a line at an angle of 30 degrees as shown in this figure. Then construct a rectangle first. Then 1, 2 will be the base of the triangle, as you can see. Then locate a midpoint on AB line, that is point 3. Then connect 3, 1 and 3, 2. That will be the top view of the triangular plane. And this will be the top view of the rectangular plane. This will be the front view of the rectangular plane like this. Then let me take one more plane, that is Pentagon, which consists the 5 sides. To draw the front view of the Pentagon, first construct and enclose this pentagon in a rectangle first, like this, and draw a line, horizontal line from BC. First construct the pentagon, and this will be 108, 108, and take the compass on the side, then you will get the E point, then you close it, that will be the pentagon. As you are aware, the pentagon, how to construct. Then enclose this pentagon in the rectangle with the construction lines by extending all this. Draw a horizontal line at point E, draw a vertical line at D and A, and from BC also you will get a rectangle. Then construct the same rectangle with the same dimensions in the front view. Draw a vertical line and horizontal line, and construct the same rectangle as we are constructed or enclosed the pentagon, in which with the same dimensions draw the front view, draw the rectangle, then take the compass, then locate point B from 2, then locate point C from 3, then take the compass with B as center with the same side, then locate point E, locate point D, then take the midpoint here. E will be the midpoint for 1 to 4, join all those lines or the points, join all those points. A, B, C, D will gives us the front view of the pentagon, pentagonal plane. Then let us see construct the same rectangle with the same dimensions as we are inscribed the pentagon in this rectangle. Then same thing, take the compass, locate point B, locate point 3 from point C from 3, then get point D using the compass, then E, then join all those points A, B, C, D, E will gives us the top view of the pentagonal plane. Now let us see the front view and top view of the circular plane. Then draw a rectangle. First I am drawing the top view of the circular plane. Draw a rectangle in the top view with a given diameter of the circle. So this will be the length of this line will be the diameter of the circle, and similarly here also. Construct a square here. Construct a square here. You will get a square. Please note that it is not rectangle, it is a square. Then locate the midpoints on the 4 sides of the square like this. Then name all those points as A, B, C, D. Then join point. Then join this point and A, midpoint of the side, rectangle, square side, that is point A. Then join point B and this corner and B, and similarly this corner and D, this corner and C. Join all those like this. Then take the compass. Then locate the intersection points where this line and this line is intersecting, and name this point as 1 and name this point as 2. Similarly, name this point as 3 and this as 4. Take the compass with 1A as radius, with 1 as center. Draw a curve which connects A and B. With the same radius with 2 as center, otherwise 2C as radius with 2 as center. Draw a smooth curve which connects C and D like this. With 3A as radius, with 3 as center, draw a curve which connects A and D or B and C like this. With the same radius, 3A as radius or 4B as radius with 4 as center, join B and C as a smooth curve using the compass. Then with 3 as center, then draw a curve which joins A and D. Then this will be the top view of the circle or circular plane. I repeat this once again, and draw a square with a given diameter. Then locate the midpoints. Then name all those points as A, B, C, D. Then locate the corner points. Bottom corner as 1. Name this bottom corner as 1 and top corner as 2. Join 1 and A, then 1 and B, then 2 and D and 2 and C, like this. Name the intersection points. As I said, this will be the 1 and this will be the 2. Then this will become 3 and this will become 4. Then take the compass, 1A as radius with 1 as center. Draw a curve which connects A and B like this. Then 2C as radius with 2 as center. Draw a curve that is going to connect C and D like this. Then 4B as radius with 4 as center. Join B and C like this. A3 as radius with 3 as center. Join A and D like this. Then similarly, to represent or to draw the front view of the plane, circular plane, same procedure is adopted, but here we have drawn the square at an angle of 30 degrees, 30 degrees, 30-degree lines. But here, so this will become the height and this will become the length. So in this case, it is a square. Construct a square like this. This will be the diameter and this is also the diameter. Construct the square in front view. Then locate the midpoints the similar way as we have did in top view. Name all those points as A, B, C, D. Then join the midpoints and as well as the opposite corner like this. And join these two midpoints and the opposite corner is this. After joining the corners with the opposite midpoints, then name this point as 1 and this will become 2. This point will become 3 and this point will become 4. Then 1A as radius with 1 as center. Draw an arc that is going to connect A and B like this. Then B1 as radius with B as center. Join C and D like this. Then B4 as radius with 4 as center, or 3A as radius in our compass with 3 as center. Draw an arc that is going to connect A and D like this. Similarly, take the same radius with 4 as center, join B and C to get an arc to complete the front view of the circular plane. Then I am taking an example here. Here is a figure. The length of the figure is 100 mm. Then height will be the 50 millimeter. But here we have the corners. We have the fillets like this. It is the radius of 25 millimeters. For this figure, we need to draw the front view and top view. Now let me draw the top view first. To draw the top view, as I said with you, in the top view, we will get only the inclined lines which are at 30 degrees with the horizontal like this. Then draw a construction line at an angle of 30 degrees on which draw a line with 100 mm length. Then represent height on this line and construct a rectangle with the length and height like this in the top view. Then divide this rectangle two halves are exactly at the mid of this rectangle. Draw a line like this which is parallel to the height. Then join the intersection point from here to the midpoint here. Then I repeat this, then draw a line from this point to the midpoint. Then draw a line from this corner to the mid of this half length like this. From this corner to the midpoint of this length, from this corner to the midpoint of this half length. Then take the compass with this intersection point and this midpoint as radius, with this as center, with this intersection point as center. Draw an arc which joins these two midpoints. Then draw a line from this midpoint to the midpoint of the width like this. Then draw a line from this point to the mid of the rectangle, half of the mid of the rectangle like this, with this as radius and this point as center. Draw an arc like this. Now draw or connect all these curves and lines to get the front view of the given figure. Now let me draw the front view with the given dimensions. Same thing, but in this case we are represented the width at an angle of 30 degrees from the top. When we see from the top, it looks like this. Or when you see from this figure, when you see this figure from the front, we have the height and length. So height, so with 50 mm, so draw a vertical line and draw an inclined line for a length of 100 mm, height for a length of 50 mm, construct a rectangle like this, and similarly divide this rectangle to get the two squares like this. Then join this intersection point and midpoint, and similarly join this midpoint and this intersection point, and this as radius. Draw a line like this. Draw an arc like this to connect these two midpoints and this intersection point as center. Draw an arc that is going to connect the midpoints of the two sides of the square like this. Then join the intersection point and midpoint for this side, and similarly join this corner and midpoint of this square side. Then take this as center and this length as radius. Draw an arc. Then join all these lines to complete the front view of the given figure. Now let us see some more figures, planar figures. Now we have a hexagon here, and inscribe this hexagon in a rectangle like this. Then draw the front view and top view. Construct a rectangle first And after constructing the rectangle for length and height, in front view we have length and height. Then in top view we will have the length and depth. But here we have length and height. In top view we have length and depth. Now same thing, if it is a hexagon, we have 60-degree lines in this case. So locate a center point here, then draw a line at an angle of 60 degrees that will intersect here, then move upwards to get a vertical line with a given side length. Then take the compass, otherwise you locate a center point here and join the edge and this edge. Similarly, in this side also draw a 60 degrees line from this line, then draw a vertical line and join the center point and here to get the front view of the hexagon. Then similarly, to construct the top view of the hexagonal plane, and same thing, in this case we have drawn the rectangle lengthwise and height-wise, but here we have to draw the rectangle in the top view first, on which you draw the hexagon with a similar procedure as we have done in front view. Locate the midpoint here, draw an inclined line from this line at an angle of 30 degrees, 60 degrees, I'm sorry. Then draw a line here with a given side, then locate a midpoint and join all these lines to get the front view of the rectangle, hexagonal plane. Then let me move further to see circle we have already seen. Then semicircle, it looks like this. Then same thing, but here we will get full circle, but here we will get the half circle. But to draw the front view and top view of the circular plane, we have to adopt the previous procedure. This procedure we have seen in the previous slide. That procedure we need to adopt. To draw the half circle also from in front view and top view, we have to adopt the same procedure. Then let me take the one more example. We have the isometric view of base pentagonal pyramid standing on HP. Let us draw the isometric view of pentagonal pyramid standing on HP. This is the problem, and for this we need to draw the isometric view. So we have the top view here. Then first, to draw the top view, construct the rectangle first, and on which inscribe the pentagon. Then after drawing the pentagon, locate the center point of the pentagon, drop a bisector, angle bisector here, and drop an angle bisector here. Otherwise, draw the midpoint, connect the midpoint and this corner A, and connect the midpoint of BC and E, and these two lines will intersect at a point, and from that point represent the height of the pentagonal pyramid. Then join all those corners, all the corners of the top view of the pentagonal plane and the apex point that we are represented at a certain height. So in this way, we need to draw the pentagonal pyramid standing on HP. Now let me take the one more example. Isometric view of pentagonal prism lying on HP. Pentagonal prism, this is a prism in which the base shape and the top shape is same. In the case of prisms, as we are discussed in previous sessions, while discussing or while drawing the projections of the solids, I told with you that if it is a prism, the base shape and the top shape is same. That means we have the uniform cross section in which the shape is same. Then if it is a pyramid, the base shape can be circular, can be pentagon, can be hexagon, but in the case of pyramids, we have an apex. And similarly, in the case of cone also, we have an apex. In the case of cone and prisms, in the case of pyramids and cone, we have apex. Then in the case of prism, the base and the top shape is same. That means the cross section is uniform. Whereas in the case of the pyramids and cones, the cross section is not uniform. That is the difference between prism and the cone, prism and the pyramid. Okay. Now for this figure, isometric view of pentagonal prism lying on HP. So to draw the isometric view of pentagonal prism, first we have to construct a pentagon in front view. Okay. To construct the pentagonal prism lying on HP, one side lying on HP, that is the case. So in that case, to draw the isometric view in such a way that one of the face is lying on HP. In that case, we need to construct a pentagon in front view first, as we have seen the construction of the pentagon in front view in our previous slide. Now construct the pentagon. Then in the problem, definitely the height of the prism will gives us. So with that height, with a given height, from A, B, C, D, E points, draw the lines which is parallel to this line, to the depth. This will become length and this will become depth. So with that depth, draw the lines and connect all those end points, which gives us the isometric view of pentagonal prism, one of the face lying on HP. It looks like this. Construct a pentagon in front view, then draw the lines which are at an angle of 30 degrees are parallel to this line. Then join all those end points to give the pentagonal prism lying, one of the face lying on horizontal plane. Then to draw the front view at top view of the pentagonal prism, first we have to construct, and this is different figure. Now to draw the isometric view of hexagonal prism standing on HP. Okay, but it is a pentagonal prism, but this is an hexagonal prism standing on HP. So now to draw the isometric view of hexagonal prism standing on HP. So that means one of the base of the hexagonal prism is lying on horizontal plane. This is what the condition given. Of course, the problem is not clearly illustrated here, but you need to assume that one of the base of the hexagonal prism is lying on HP. In that condition, we have to draw the isometric view. Then construct a hexagon in the top view with the given dimensions. Then the height of the hexagonal prism will also gives us in the problem. With that height, from all the points, 6 points, 1, 2, 3, 4 are A, B, C, D, E, F. Then represent the heights or draw the vertical lines like this. Then connect all those end points to get the hexagonal to get the top face of the hexagonal prism when one face is lying on HP. With this you can see the bottom face is lying on horizontal plane, right? In that case, he is asking us to draw the isometric view. To draw the isometric view of the hexagonal prism such that one of the face is standing on HP, first construct a rectangle with the given dimensions, then draw the hexagon first, then from all the corners of the hexagon represent the height with a given height of the hexagonal prism, then connect all those points will gives us the figure or the isometric view of the hexagonal prism. One of the base is lying on HP. Then represent the other lines, and these two lines will be the dotted lines. These two lines are not thick lines. We need to represent these two lines as dotted lines. Of course, here it is shown as thick line, but please make a correction that these two lines are dotted lines. But here also we will get two dotted lines which are not represented here. One line is an inclined line like this, then one line is parallel to BC, we will get one line, and one more line we will get as a dotted line which is parallel to CD from this corner. So we will get the two lines parallel. So one is parallel to DC, other one is parallel to BC. Both will meet at a point that we need to represent. Then let me move further to see one more figure. Cylinder standing on HP. That means one of the base of the cylinder is lying on horizontal plane. That is a condition. This is the one problem we need to draw. Then first I would like to draw the cylinder lying on HP. As you can see, first draw the front view. That means cylinder surface is lying on HP, not the base or the top face. Bottom face or not the top face is lying on HP. The surface of the cylinder is lying on HP. Then to draw the isometric view of the cylinder when the surface is lying on HP, draw the square with a given diameter in front view. Then draw an ellipse by using the previous procedure for the planar figure. When we see the circle in front view, how it looks like this, that we are already discussed in our previous slide. After constructing the front view of the planar surface, then project all the corners of this square with a given height of the cylinder. Then construct the other face of the cylinder in the square with the same procedure. Then join these and draw a tangent for these two ellipses, and also join or draw one more tangent at the top and one at the bottom to give us a cylinder lying on the horizontal plane. Exactly this line will be the dotted line. We cannot see that corner of the cylinder when we see from the front. Then let me draw one base is lying, one base surface, either top or bottom face lies on horizontal plane. In that case, let us draw the isometric view of the cylinder. Now in the top view, construct a square. In the square, draw an ellipse. with the previous procedure that we have seen in our previous slide. Then project all the vertical lines from the corners of the square and on the top, and join all the corners on the to get the square at the top. Also construct one more ellipse here. Then draw the tangents for these two. Then this edge will be the dotted line. Okay, if we want, we need to represent as a dotted line, otherwise we can do. So that will be the cylinder standing on HP. One of the face of the cylinder standing are lying on HP, and the cylindrical surface is lying on the horizontal plane. But in this case, one of the face, top or bottom face, is lying on HP. Then let me see the half cylinder also. As you can see, so similarly, same thing will happen, and construct one square here with a given diameter, represent or construct the or draw the half ellipse with the previous procedure, and similarly to the back side also draw an half ellipse, then join these two curves, elliptical curves, with a thick line, then join all these corners to get the half cylinder lying on HP. The half cylinder surface is lying on HP. And similarly, and half cylindrical surface, and in this case it looks like this. Same thing will happen. And similarly, let me take one more example, that is isometric view of a frustum of square pyramid standing on HP on its larger base. That means there is a frustum of square pyramid. In the previous sessions, I told with you that frustum of the solid means the sectioned plane is parallel to the base. That means the surface that we get after doing this section will be parallel to the base. So this is a frustum of a square pyramid. That means the base shape is a square, and we are doing section in such a way that the sectioned plane is parallel to the base. Then we are calling that as frustum of the square pyramid. Now the height of the square pyramid is 60. Then on the top we will get a square. We will get a square that is 20, 20, 20. The bottom we have one more square that is 40. Square of side 40. On the top we have a square of side 20. Then the height is 60. These are the given dimensions. This will be the top view and this will be the front view. So with this front view and top view, we need to draw the isometric view of the frustum of square pyramid with the given dimensions. To draw this, first we need to draw the base first. Base first in the top view as like this. Base, the side is 40, 40, 40. Then draw the vertical lines from here because it is resting on the horizontal plane, so that I am representing the base on the horizontal plane. Then draw the vertical lines from these three corners or the four corners with a given height that is 60. Then join all the end points of the vertical lines like this. Then draw the midpoints like this. Then on these lines or on these bisectors, then locate the 20 mm and 20 mm on this, and from this intersection point and up to here it is 10 and 10. The distance between these 2 points are 20 and 20. Locate the 4 corners of the top view on these 2 perpendicular lines. Then join all those points. Then join this corner and on the bottom view like this. Then join this point and this point. And these 2 edges we cannot see. These 2 edges must be the dotted lines. So this is what the isometric view of a frustum of square pyramid. This is the way we need to draw the isometric views from the given orthographic views. In the next session, we will take a few more examples and try to draw the isometric views. Thank you, one and all. I will stop here now.